Welcome to Lesson 3 of Applied Physics. This lesson covers experimentation and graphing. Experimentation in physics is done to acquire data in the hopes of recognizing some repeatable behavior of matter. Thus, the manner in which the experimental investigations are done and reported are very important for success. There are several skills that must be acquired in order to make a report on a successful scientific investigation. Among these skills are the ability to follow careful procedures, create a proper graph, analyze error, and write a technical report. In this lesson, you will cover the following objectives. You will learn about the importance of keeping good records and notes when doing experiments, and you will understand relationships such as linear and quadratics when graphing data. Your instructor may have specific instructions or requirements for recording data that he or she may want you to follow. The following items can be considered general guidelines. Use a bound book, such as spiral bound or with sewn-in pages. The objective is for the pages to be sequential and not susceptible to being lost. Begin recording information about each experiment at the top of a new page and record the title of the experiment at the top of that page. Enter into the notebook the date the information was gathered. Record model numbers and/or brand names of instruments used if available. A schematic diagram of the lab setup with an outline of your procedures will make your lab notebook useful even without the lab manual. Organize the data in tables. At the top of each column should be the variable and the unit of measure of the variable. Check the instrument used for the scale divisions if the lab instructions do not provide that information. Numbers must always have some identification as to what they represent. Instructions on creating proper data tables are given later in this section. Review these instructions if necessary. One-of-a-kind observations should be placed in lists. If you think you made an error, do not erase. Draw a line through the possible erroneous information and record the corrected data next to it. If you find later that there was not an error, the data will still be available. Whenever questions occur to you or a problem arises, make a note of it in your notebook. This includes such things as difficulty in taking a measurement or equipment problems. This may be useful later when considering the results of the experiment, or it may suggest other experimentation. Your instructor will ask you to write a formal report, or you may respond to questions based on information recorded in your notebook. To fully benefit from the experience of having performed the experiment, it is helpful to approach each experiment as if you designed it yourself. That way you will have the best understanding of what you were trying to observe and what you did observe. Keep in mind that the neater and more organized you are, the easier it will be to write reports and/or make conclusions based on your results. The following information will help you get started in organizing your experiments. A sample experiment will be used to illustrate the points. Each of the basic areas covered in this applied physics course will have a capstone type activity which will be used to assess your learning. One of the ways that a technician can communicate their knowledge and information to their employer or their teacher is to create a lab notebook report which provides the necessary information so that reproduction of an activity can be done by whomever reads the report. Define as clearly as possible the phenomenon to be studied. Suppose you wish to study the phenomena of sound detection by the human ear. More specifically, you wish to find physical variables that are related in determining the threshold of hearing. You might write in your laboratory notebook something like, "This experiment will investigate the factors which affect the threshold of human hearing." Describe the physical variables and determine how each is to be measured. Good experimentation calls for the control of all relevant variables and deciding on how to measure experimental effects as each variable is changed while others are held constant. In this hearing problem, the possible variables you might think of are loudness, intensity, pitch or frequency, duration of sound, weather conditions, time of day, physical state of the subject, mental state of the subject, and location of the experiment. Some of these possible variables could be quickly eliminated from consideration by showing that they have no effect on the perception of sound or time of day, while others might play a role that is not easily measured, mental state of the subject. Physical variables such as intensity and frequency of sound stimuli can be controlled. Design your experiment to maximize repeatability and minimize experimental errors in the measurement process. In our sound experiment, this would mean designing an experiment where other physical variables such as temperature, light, and comfort of the subject can be controlled. The response of the subject when sound was heard is the experimental output that will be measured as a function of the controlled variables, intensity, and frequency of sound. In this case, you would want an indication that sound is heard as you vary the intensity at various frequencies of sound stimuli. Do you start with audible sound and reduce intensity, or start with zero intensity and increase to audibility? You want a clear, unambiguous response from the subject for each input stimulus. You also would want a sound-generating system that would allow you to measure precisely the intensity and frequency of each input stimulus. Oftentimes, a flowchart will help you make your decisions prior to conducting an experiment. Flowcharts are useful tools in helping somebody actually doing science. Decide how the data will be organized and presented. Have your data tables in your lab notebook ready to receive data before the experimentation begins. In your lab notebook, note the limitations of your equipment and procedure with error analysis in mind. As the experiment proceeds, note data that has any question about it. With these experimental requirements met, your data would be a table of minimum intensities of sound required to hear sound at different frequencies. You might present this data as a plot of intensity required for perception of sound versus frequency of sound. The intensity required for perception, the dependent variable, is plotted on the vertical or y-axis, and the frequency of the sound, the independent variable, is plotted on the horizontal or x-axis. The experimental errors in this experiment would include the range of intensity levels that are found as the experiment is repeated a number of times. This could be illustrated on the graph by error bars, including the range around the average value of threshold intensity at each frequency. Analyze the results of your investigations and state a conclusion. The graph line that best fits all the data clearly indicates that the threshold of sound depends on the frequency of the sound heard. Much of the data that you collect in lab should be put into data tables for your lab report. The purpose of a data table is to put repetitive data in a neat, organized form where it can be easily interpreted. A properly written data table should clearly indicate what was measured and the units that were used. It is also useful to indicate the symbol that will be used to represent the measured quantities in your report or calculations. This information is indicated in the row or column headings of the table, not in the body of the table itself. Note that the data is very repetitive. The same quantities are measured over and over. If the data were presented in this form in a lab report, getting any information from it would be a tedious task. Because of the repetitive nature of the data, it is best presented in a table. The two quantities measured were voltage and current. From her notes, we see that the voltage was measured in volts and the current in milliamps. A table for this data would have two columns, one for each of the measured quantities, and the headings would indicate voltage and current with appropriate units. The headings of the columns would also show the symbols used for the measured quantities, in this case V for voltage and I for current. The table would have 10 rows, one for each set of measurements taken. Shown below is a proper data table for the student's data. Note that within the body of the table there are no units. To see which units are associated with a number, look at the column headings. This example is a very basic one. Not all the data collected in an experiment will fit into a basic table like this one. Sometimes there must be headings for the rows as well as the columns, while other times you may need subheadings. Creating an understandable, sensible data table is really as much an art as it is a science. The ability to make good data tables will come with practice. For every lab that you do, put your data in tables whenever possible. If you're not sure how to put the data for a particular experiment into a table, ask your instructor for assistance or suggestions. For examples of other types of tables, look on the internet. Also, there are many examples of tables throughout the text. Now, take some time to record this data in a program like Excel or search for a simple graphing program on the web. An example can be found at this link. Once the data is recorded, use an XY scatter plot for graphing and draw a graph. Then do an analysis of the best fit line for the graph. What would this graph say about voltage and current? Hopefully you can see a relationship which you have studied in electrical theory known as Ohm's law. Quantitative experiments are performed to understand the relationship that exists between the measured variables in the experiment. Throughout the performance of an experiment, one variable, called the independent variable, is carefully manipulated. The value of the variable that responds to each manipulation is recorded, and this quantity is referred to as the dependent variable. Both values generally make up the data. This data is then used to plot a graph. The interpretation of the graph will be the method of establishing the relationship between the variables. Complete the self-check to see if you need to refresh your knowledge of graphing. You can use Excel or the graphing program you used on the previous page. Check your understanding of graphing. You can use Excel or the graphing program you used on the previous page. For a set of data with two variables, it is customary to use the horizontal axis for the independent variable and the vertical axis for the dependent variable. The independent variable is generally that quantity in an experiment which was varied by the experimenter, while the dependent variable is that quantity which is measured as the independent variable is changed. The value of the dependent variable depends on the value of the independent variable. The type of graph that we shall use is called the Cartesian graph, since it is based upon the model of space suggested by René Descartes, a 17th century French mathematician. Each axis is marked off with an appropriate scale. The scales on the two axes need not be the same. An ordered pair of numbers, x and y, names a particular point on the coordinate system. The first number gives the location along the horizontal axis, while the second number indicates the location along the vertical axis. As an example, the point 4, 2 has been plotted on the coordinate system. Graphs are used to show the relationships between quantities. Graphing is a way of picturing how one quantity changes in response to changes in another quantity. The relationship illustrated by a graph is represented by a line which is the best fit to the data. This line, which may or may not be straight, is known by the general term curve. Keep in mind that a curve on a graph may be a straight line. To see these relationships, consider the following curves on the graphs and answer the questions for these curves. All straight lines belong to the family of linear relationships. Straight line graphs are characterized by a quantity known as the slope, which is related to the steepness of the line. The slope is the ratio of the change in the vertical data to the change in the horizontal data. This is sometimes taught in algebra class as the rise over the run. When graphing physical data from an experiment, the slope of the linear graph generally has physical meaning. The quantities graphed have units associated with them, so the slope will have units as well. For example, suppose you plot a graph with position, measured in meters, on the vertical axis, and time, measured in seconds, on the horizontal axis. The slope is the change in vertical values over change in horizontal values, or in this case, change in position over change in time. What would the units of the slope be? What would the physical meaning of the slope of the line be? When graphing data from experiments, the slope almost always has physical meaning and should be reported along with the units in physical interpretation. Hence, a position versus time graph will always give you a slope which has the physical meaning of speed. It's all in the units on the graph.